So you'll notice from the color coding on the chart, we're taking a little bit of a side track, but a very important one. We've been doing scalability all morning, but Tom's schedule didn't allow him to be with us at any other time. So we're going into the cloud right now. Right? Is that a good introduction?
Good enough, Bill. Thank you.
Right, okay.
Would you like this?
Sure.
That way you can run. Fairly close to your
So actually, the reason why I can't be here more than a part of today is because my youngest son is going to the world first robotics competition, and we're leaving tomorrow. So I got to head off to that. Otherwise, I'd love to spend some more time because I'm really fascinated with this. So I'm not a big expert in the RDMA, but I've always thought InfiniBand is really an interesting technology, and especially with digital storage, which is the things I look at. And one area in particular I look at is in digital storage in professional media and entertainment. And in fact, if anyone's interested in that, I do a report on that subject. I can tell you more about that. I also do some conferences related to that. So we're going to talk a bit here. And I want to thank, by the way, Paul and also Jim for inviting me to come here. And Jim provided me with a whole bunch of interesting information on this concept of clouds, or if you will, storage at a distance. And so I decided to expand that a little bit and talk about clouds at a distance here. And since I do things in the media and entertainment space, just to give you a little bit of idea where this is coming from, as most of you know, of course, media and entertainment is ending up being pretty big stuff. And it has elements of it, like the rendering and special effects and things like that, which have a lot of similarities to high-performance computing. So but just looking at some of the trends going on here, we're ending up with richer content as people try to create more immersive experiences that can pull people into a piece of entertainment or into the news, whatever's going on. Frame rates traditionally were 24 frames per second, which is set by the technology of getting a good image with minimum frame rates for film. But going into digital technology now, we have a lot more capabilities to use technology to accomplish, again, these more immersive experiences. So, for instance, The Hobbit was done by Peter Jackson at 48 frames per second. And the Avatar follow-on movie is being done at 60 frames per second. There's actually professional video cameras out there that run up to 120 frames per second. And there are folks that are talking about 300 frames per second as being rather useful. In fact, there are special effects that are done at very high frame rates. If you remember the Sherlock Holmes, recent Sherlock Holmes films, they're showing the slow motion stuff. So they had a special camera that ran 3,000 frames per second that could capture that kind of content. So they can now run there's some films that can run, say, 1,500 frames per second at 4K. So just some of these trends here, which could have an enormous impact in terms of both the bandwidth and storage requirements for this kind of content. Also going into not only higher frame rates, but 4K production commonplace, but 6K and even 8K, that's 8K by 4K, sort of projects are not out of the question. Video resolutions, even 16K, as people are talking about. That gives you something like an IMAX kind of experience. The Ultra HD, this is a 4K for broadcast, for whatever you want to call it, TV, or even 8K, so 4K by 2K or 8K by 4K content. There's a lot of work being done, particularly by the Japanese broadcast company, NHK. They've been doing steady progress. The Summer Olympics last year, there was stuff that was shot at 8K content. They've developed actually portable field cameras, and there's projection systems, a lot of which have been 4K slaved together. But there's even Sharp has been demonstrating the last couple of years an 8K by 4K display at some of the technology shows. Right now, if you go to this CES or other shows like that, you can see 4K displays. There's a lot of people offering these things. I think there's something like $1,700 or something like that right now. But if you remember, HD, what we now call HD, had those kind of price ranges too, and it wasn't that long ago. This stuff happens, and it happens fast. It's going to drive an enormous amount in terms of the demand. So there's the 8K content was shot at the Summer Olympics. It was shown in some select spots, both in England, in the US, and also in Japan. If we put a bunch of these things together, the video resolution and frame rates, increasing storage projects multiply, storage capacity and bandwidth become pretty extraordinary. For instance, if you go to what seems ridiculous now, but may not in the future. If we go by a 16 by 8K pixel resolution, 64 bits per pixel, 300 frames per second raw video content, we could be talking about hundreds of gigabytes per second data rates and over a petabyte per hour. We could be looking at projects that could be an exabyte. You know, typical movie projects now, some of them are getting in the several petabytes range. You could have that multiplied by 100 times. You could be looking at exabyte projects, you know, video projects people are doing. So if you think about what that means in terms of the bandwidth and storage requirements, it could be pretty daunting. Just some examples, again, another way of looking at this, just showing some tables on resolution, frame rates, required data rates, and storage capacities for some assumptions on different types of, forgot I had this, different sorts of content resolutions here. So here's that 8K by 4K, one example of an 8K by 4K. And again, we could be talking about, 86 terabytes per hour of the raw content for something like this. Now, this is different, of course, if you get into, the actual transmitted content. But you want to capture stuff generally as high a resolution as you can, and not sacrifice too much in terms of the bandwidth. But if you go to this 8K ultra high definition, it may use more than 100 times the capacity, that raw capacity, as today's high definition. And also, if you want to try to get this experience out to the customers, although there are big advances in terms of compression technology to make use of the channels that are out there, like recently HEVC, still you're going to have a trend that as things get higher resolution, more immersive experience, that they're going to be chewing up a lot more resources. And even the HEVC has some issues in terms of the processing power required to do that kind of subjective-based compression technologies that they're talking about being actual transport 4K content through conventional cable and other transmission channels use this technology. But if we look at just some scaling of the size of typical multimedia objects going all the way from ASCII page, in terms of the size of the objects in gigabytes and the data rates here, we're looking high definition movie today, a Blu-ray movie would be tens of gigabytes. We could be looking at 4K sort of content, even with the compression may end up being over 100 gigabytes. There's talk that maybe you can go to 50 with HEVC compression, go to 50 gigabytes, which would put it on a 2-layer Blu-ray optical disc. But ultimately, if we go into an 8K type content, we're definitely looking at hundreds of gigabytes or more. If we try to go into a truly immersive experience, which I think we could be looking at the capabilities of moving to this within the next 15 years, where you might be able to get something like free-floating holograms. And the number of cameras you'd require in order to capture something like that, the number of if you will, rendering for each of those positions, not just in a two-dimensional space, but actually given a real three-dimensional projection, could be quite daunting. But with capabilities developing both, bandwidth, processing power, including things, some of the high-performance computing stuff applied to this, we could be looking at objects that would end up be able to provide that kind of content to either a theater or possibly to somebody's home. We could be looking at over a terabyte for that content. And just from my report, here's some projections on the capacity growth for the creation of video content. That this is total capacity in petabytes, so we're looking at approaching several exabytes of content within just a few years' time to be able to provide the increasing level, the amount of content's being created, increasing resolution, frame rates, and the raw amount of content that's being captured by people, which with digital technologies are encouraged to chew up a lot more than they were with the older analog technology. Oh, there we go. So movie workflows, ideally they want to use some kind of shared storage that everyone can work off of. They flow the content into it, whether it comes from rendering or cameras, etc. And then they transcode it for delivery to all the different channels. And finally, they want to keep a copy for the future because this stuff has significant potential economic or cultural value. Unique features of some of the areas in media and entertainment, although there are similarities to other areas, there's no pauses in real-time streaming. No drop frames for the real professional stuff, not Netflix. Increasing resolution demands, particularly for the original content, drive very high data rates, and the latency requirements, especially doing this video editing stuff. It's essentially an artistic function. You don't want you want the lowest latency. You want something that's not noticeable. for capture and editing, and other post-production work as well. But there also are some areas like distribution, et cetera, where maybe the latency is okay as long as once it streams, it keeps on streaming. So there's some different requirements in different areas. If we get into that professional, the content creation side, what's interesting is if we have someone that's doing some of these post-production activities, they may have local storage of various sorts here, including maybe hard disk storage, but DRAM. And then they're usually, especially if it's someone who's working in a facility, they might have a seat that's connected into a local network. So they'd have either a block or file-based access. But there also are some interesting areas where, especially in order to encourage collaborative workflows and things like that, where there's a number of people that are starting to use the cloud. In a survey that we did of professional media and entertainment professionals, we found that there was getting to be a not inconsiderable amount of people who are starting to look at the cloud to help in some of these workflows, especially because especially film projects may occur over many different areas, occur across continents, for instance. So there's some other statistics down here too. I think you guys are going to get the slides later on so you can take a look at those. So can post-production be done in the cloud, or what amount of it can be done in the cloud? This not only your editing is generally done with uncompressed or at most slightly compressed content. Heavy compression, if it's not done right, can lead to loss of resolution or timing issues, various sorts of things that cause artifacts. Actual editing may end up using lower resolution proxy content and then creating a list of changes in the original content that then you do this confirmation to actually transfer to the original content. There's this movement towards collaborative workflow where people are actually using the web, using the cloud to be able to work on content in various areas to be able to move it around. And while the latency of remote access through the internet may limit the use of cloud storage for direct creative editing, it has been starting to be used effectively for compute-intensive operations, one of which is rendering, which again is a good analogy to high-performance computing for special effects, that sort of thing. Transcoding, content distribution, and archiving. Those are areas where indeed the cloud has an important role in the video workflows. Let's see, I'll go beyond this one. But let's look at in media and entertainment content. Cloud offerings are, as in many cases, an outsourcing approach. Instead of building my own rendering facility, which I may not use all the time, I will rent some time on someone else's equipment. But there's new capabilities enabled by the rise of remote services, as mentioned before, collaborative workflows. There are methods now using the internet and special internet conditioning and multiple channels, such as spare and bit speed, to try to move content around very quickly through the network. New cost-effective services through the cloud enable greater sophistication for smaller shops. So essentially, you could do an OpEx on a budget to give you the same capabilities that someone who could spend a lot of money on their own facility might have, or at least approaching those capabilities. Also, there are various vendors offering cloud archiving services. I'll show some examples of that shortly. And those cloud, of course, it's a big data center, so it drives a whole bunch of different layers of storage devices that may actually be used, including flash memory, tapes, and hard disk drives. And I see there's some flash memory sessions later on in the week here too, which SSD type sessions look very interesting. So some storage system trends, virtualization, dedupe, software-defined storage, also working at getting lower cost storage devices like Open Compute Project, replication erasure codes to try to create greater reliability with existing equipment. And in addition to that, there's a whole bunch of things happening on the consumer side. In terms of some of the storage and the cloud stuff that's going on now, there's some interesting, and some of these may seem a little odd, but with the rise of file-based tapes, actually there's efforts to be able to put archiving with tape-based archiving, such as Fujifilm announced with their PermiVault in 2011. And at the NAB this year, they talked more about this. They're using LTO tape accessible in the cloud, essentially, for an archiving service. That's an LTO, this LTFS file systems available on the last generation LTO5 and also LTO6 tape. And there's various people, such as Front Porch, using this also for these archive applications. There's people that do encoding of various sorts on the web. Some examples given here. And also there are folks that are using, again, trying to get into some, like Nirvonics, trying to get into some of these collaborative workflow where the content may be available through a cloud-based service. So could the cloud be used as a central storage for post-production? Could this become that centralized storage? Everything is outside of the facility. So the question there is, what would it take to provide extremely low latency beyond what human beings would notice? Because you're dealing with human creative activities generally here, online storage at a distance. So that's where this remote RDMA, remote direct memory access, perhaps it could play a role there. Modern communication paradigm focused on ultra-low latency and very high bandwidth. As most of you know, InfiniBand has a good example of that. The other one's iWarp and this ROCE. Achieve currency in high-performance computing and other performance or cost-sensitive environments. And these are actually some slides borrowed from Paul, and I thank him for the use of that. But basically, can we essentially tunnel through the internet to provide access, more direct access without going through basically all the switching and the things which would slow down the access of information and its use, which could allow you to do more things, especially in this industry. So you can achieve full wire speed, keeping the pipe full of data. The transport protocol fundamentally different from TCP, again, avoiding a lot of that switching and the extra overhead you have. You can measure packets, not bytes, in flight, and you can have a whole bunch of different packets moving over the net. So again, all these ways in which you can keep more data flowing. And so you can get, again, trying to get that full wire bandwidth, whatever the capabilities is available. So the other thing is it can drop the overhead on the actual systems that are using it because things are being handled in that network. So the memory bandwidth demand is reduced, CPU utilization is reduced, eliminated, and your network bandwidth not gated by this processor speed. So you get more effective use of your local resources, again, by doing this activity through the net. So whereas in the background you have traditional IP routing, this allows you more direct access. So going at lower levels, you can then go through the fabric to be able to access data. And then can you do some kind of collaborative activities between multiple people? If a piece of content is over here, that multiple workstations, in this case they could be video professionals could be working on this to access that data. And the remote file system, at least in some respect, acts like it's local. So if you did this, and particularly I'm thinking this is just in general, but if you could do this in the media and entertainment space, you might even be able to get more efficient file transfers, okay? We actually are trying to, first of all, you can more effectively deal with things you're doing in the web itself. For instance, I've already got content in the web, I can transcode it, I could do the rendering, I could do things like that. But in addition, I might be able to move files around between facilities where, for instance, even if you can't do the real-time editing, you could still download content and do your piece of it there, and then get it, and then move it back up to provide faster collaboration. So this efficient transport for long, fast networks with basically get good bandwidth utilization. So there may be a possibility there. Okay, this is the collaborative workflow, and that was the file transfer. File transfer, I think, has the best odds to be more effectively doing that. The question might be of, especially if you're dealing with uncompressed content, whether you could effectively do that over the network. Can you have this be your basic storage? But my general conclusion summaries here is that demand for high resolution content, higher frame rate, higher resolution is increasing. This could become extremely large. They're very large data sets that we need effective ways to be able to move and use these things. And I think the direct memory access and approaches like this could be an important tool in accomplishing that, which is what I wanted to get across here. If we get larger data sets, the bandwidth increases, and these activities that want to be real time and download and be able to both make and distribute content around and presumably then be able to monetize it will increase. Cloud-based services playing an increasingly important role in making these happen. And again, these direct memory access technologies may assist us in doing that. and especially to create these more collaborative video workflows. So the question then at the end there here is, how far can we go to take these RDMA and other sorts of direct memory access, again, with faster storage technologies, with the network bandwidth available to us? Just what all can we do in terms of making these sort of collaborative processes work, or perhaps even in enabling new sorts of technologies and new sorts of applications that could result from that. So that's my talk, and I think I used about half my time.
Yeah, you did a great job, Tom. So
Thanks.
So there's several people in the room that I know have interest in this area. Can we have some questions for Tom around video post-production and wide area access to storage? Come on, Lyndon.
So you mentioned this desire to be able to do this in a distributed fashion among a team that's in different places.
Right.
I think there's no free lunch. You do need to have a very capable network between those places.
You probably got to have a real fat line yourself, yeah.
So I guess the question I have is there a stable enough production environment here? I'm assuming there's money. There's a lot of money in these production environments, but is there a stable enough production environment to make the investment in infrastructure to do this kind of thing across geography?
Well, a lot of it is done on a contract basis, so rather than having fixed employees, in the case of movies, there's very few people who actually work for the movie company, but there's an awful lot of people that do projects. But some of them are in facilities, which actually have employees, editing facilities, things like that. It may be worthwhile for them to make an investment to have those resources available.
Yeah, I mean, I think the economy of the cloud applies here. So you have a shared storage, common storage environment, then if that has the performance that's needed, then each of the individual productions don't have to pay for that.
Right.
You pay for it once, but each of the individual productions do have to pay for connectivity.
They have to pay, somehow you have to pay for the connectivity, whether you do it all at once or you do it on an incremental basis. I think what this allows is again, being able to have incremental payments rather than upfront payments. That's why I said, to a large extent, a lot of this stuff really is an outsourcing play. Yeah. Or pay as you go, those kind of concepts.
So it's my understanding that the sporting industry has kind of already gone down this road. We had a presentation at User Day that the Major League Baseball franchise has done something like this, and they've put in their own infrastructure, and so it seems like the Major League Sports is already going down this road.
Yeah, a lot of people, especially doing live stuff, and they've got to transport a lot of content very quickly. And sometimes it's streaming, but sometimes it's also sort of a caching and then in a streaming. And to be effective, a lot of times, especially for that content delivery, a lot of it is that you've got to have the back, so you cache something up. You may have some latency on the initial cache. It's not as real time as if you're actually watching the game. But once it starts, it keeps on playing out. You don't get interruptions in it. And like if you have these content delivery networks or other ways in which you can deliver content, which have changed an awful lot from the older technologies. But can you use this RDMA as an approach to accomplish things like that? And I think that's a very interesting concept of whether you can augment the current ways in which we try to speed transport by using these techniques, and maybe reduce some of the overhead on the devices that are connected and are using the network.
You mentioned compression. What level of light compression do you need where you can still get pixel accurate processing on the video? Pixel accurate processing?
Okay, so the compression, of course, depends upon the content. Some content, can be compressed more than others. And so it's very content dependent on how much new information is in adjacent frames. And sometimes you can concentrate on just the areas that are changing, but also some of the new compression technologies like this HEVC, the MPEG, the H.265, would provide what they call a subjective compression algorithm that tries to get rid of it's a lossy compression, but it gets rid of content where the algorithm tells you will notice it less, and therefore it can accomplish levels of compression that are beyond that of H.264.
So you can get 10 to 1 kind of compression ratios?
It's about half again.
Half again.
Yeah, as I understand. But again, it depends on the content. So, but if you take an average of something like that, but it requires, especially at the NAB still this month, sorry, is that there was a lot of talk about the difficulty in implementing it because of the processing requirements increase about 10 to 1.
And how about latency?
Well, let's see. I don't know if it's going to impact you that much on latency, except the usual buffering things. In fact, if you can compress, other than the time to do the processing, if you lower the size of the payloads, then you're going to reduce the, you're going to increase the speed of transport, and so at least you lose that latency.
Okay, thanks.
So, but again, it requires technologies that maybe we're a few years off from being able to build in large volumes. It's sort of still more of a demonstration than an actual distribution system, which is kind of bad for the 4K TV set guys, because they need some way of getting the content to you. So maybe you can do HEVC on 2-layer Blu-ray discs, but then you still have to have the decoding, which is like 2 to 1, 10 to 1 on the distribution side, 2 to 1 on the decoding side. So you're going to have more intense processing on the Blu-ray players or something like that to be able to play out that sort of content. So maybe we're going to see a new generation of the consumer devices with some higher performance processing for that. Sorry.
Any more questions? So I'll just say something about something that I know of that you might be interested in.
Okay.
And so you perhaps can. I don't know how many of you are aware of an organization called ESNet, or the DOE lab people are, but no, you don't know anything about it. It stands for Energy Sciences Network, and it's the network that the Department of Energy funds for high energy physics actually around the world. They have transatlantic connections, and have a very close working relationship with Internet 2, which is the organization that the National Science Foundation funds for the evolution of the Internet within the US. Mm-hmm. Well, between them, they actually have 100 gigabit bandwidth in place and available for use. Free. Magic word, free, right? I don't know if there's anywhere else in the world, as you might know, where you can get access to a 100 gigabit network for free. So what it takes to get access to it is to put in a 2 or 3 page proposal to describe what research you would like to do on 100 gigabits of bandwidth.
Interesting. Yes.
Yes, I thought you'd be interested
Yeah,
in
that
this.
is interesting. I'll look into that.
Right. So it's actually managed out of Lawrence Berkeley Lab in Berkeley. If you're interested in a contact there, be happy to provide that. But you can find it on the web. If you Google ESNet testbed, you'll find it. Okay? They have a very interesting piece of software that you'll also be interested to learn about.
Still have a little more room.
It's called OSCARS, OSCARS. And what it does is to establish a layer 2 path or flow across a wide area network running MPLS, right? And so what it enables you to do is to schedule a layer 2 flow across a now traditional carriers network running MPLS, and you can turn on your layer 2 flow and have it run, and then you can turn it off. People have wanted high bandwidth on demand for a long time, right?
Yes.
This is a piece of open source software. You can download it from from ESNet's website and use it.
Fascinating. Thank you, Bill.
And I think for those of us that are interested in very high performance, wide area networking between sites using RDMA, this is the underpinnings for doing that. If you have any stronger interest than the 2 websites I've just pointed you at, then talk to me. There are projects experimenting with this. You probably can find it on the ESNet website, right, of what people are doing. And if you want a person's contact name, there, Brian Tierney, btierney@esnet.gov probably, right, is a contact point.